Hi. Today we shall be doing a simple regression model, and here we have we have four variables such as y, x1, x2 and x3, and here y is the dependent variable and others are independent variables. Okay, so the variables are here. So here are the variables. You can see from here. This is observation from the year 2000 until 2007, x1, x2, x3 and y. And here y is the dependent variable. Okay. So first we shall estimate the model. So I go to statistics, right? Then I go to linear models and linear regression. Okay, and here I choose dependent variable y and independent variable x1, x2, x3. So we have three variables, right? x1, x2, x3. Then I press OK. Yes, the model has been estimated. You can see. So it is the y dependent, x1, x2, x3 are the independent variable. Okay, here y is the dependent, x1, x2, x3 are the independent variable. And finally this is constant. Constant means actually intercept of the model. Okay, first I talk about x1. The coefficient is 0.466. So that is coefficient, standard error, t statistics and corresponding p value. So here t statistics is how much? 3.75. So how to get this 3.75? Actually coefficient, that is 0.46661 divided by standard error, you can get the t statistics, that is 3.75, and this one is the corresponding probability, that is called 2% here, right? 2% probability. Okay, now the question is that which variable is significant to explain y, right? That is the first question. Okay, first I check about x1. x1, this variable is significant because the probability value is only 2%. So normally when the probability value is less than 5%, then that particular variable is significant. But if the probability value is more than 5%, normally we say that variable is not significant. So here the probability is 2%. So the x1 is a significant variable to explain y, and the coefficient is positive. You can see the coefficient sign is positive, meaning that if x goes up, y also goes up. If x goes down, y also goes down. Okay, then what about the second variable, x2? What is p value? 73.6%. 73.6%, which is more than 5%, meaning that x2 variable is not a significant variable to explain y. Then what about x3? x3, what is the p value? 23.4%, which is more than 5%, meaning that x3 is not a significant variable to explain y. Okay, so here I can see only one variable is significant, that is x1, and the coefficient is positive, meaning that x1 and y has a positive associationship. Okay, this part is done, but x2 and x3 are not significant variable to explain y. Okay, now the question is that whether this x1, x2, x3, whether these three variables jointly can cause y or not. I am telling again, whether x1, x2, x3, these three variables jointly can influence y or not. That we want to check. So we can check it from F statistics, right? And corresponding probability. You can see the probability, F statistics, and corresponding probability, and we call it joint significance test. Okay. Okay, so what is the null hypothesis? Null hypothesis is these three independent variables jointly cannot influence y. That is our null hypothesis. And what is our alternative hypothesis? x1, x2, x3 jointly can affect y. That is alternative hypothesis, right? Okay. Okay. So what is null hypothesis? x1, x2 and x3 jointly affect y, right? Okay, sorry, jointly does not affect, sorry, jointly does not affect y. And what is alternative? x1, x2, x3 jointly affect y. That is alternative hypothesis. Okay, and here is the probability value is how much? 8.35%. That is the probability value. That means more than 5%. So meaning that we can reject the null hypothesis and can accept the alternative hypothesis, that is x1, x2 and x3. These three variables jointly affect y. Oh sorry, here I have done mistake. Sorry, I'm telling again. Here the p-value is 8.35%, meaning that more than 5%. So we cannot reject null hypothesis. Rather, we accept null hypothesis. So normally we can reject null hypothesis when the probability value is less than 5%. But here we cannot reject null hypothesis because probability value is 8.35%, which is more than 5%. We cannot reject null hypothesis, rather we accept null hypothesis, meaning that x1, x2, x3 jointly does not affect y, right? Okay, jointly does not affect y. Okay, then we can talk about r square. What is the value of r square? Okay, here r square value is 78.04%, right? 78.04%, meaning that 78.04% variation in y can be caused by x1, x2, x3. I am telling again. What does mean by r squared? 78.04%. It means that 78.04% variation in y can be caused by three variables such as x1, x2 and x3 jointly. So meaning that x1, x2 and x3 jointly can cause 78.04% variation in y. So meaning that the data is fitted very nicely. Data is fitted very nicely because x1, x2, x3 can cause 78.04% of variation of y, right? And but the problem is that, so this part is very good, data is fitted well, right? But the problem is that F statistics is not significant. So that is a bad side. That is a bad side because F statistics is not as significant. But the thing is that R squared is very high. That is a good sign. But the thing is that we are more concerned about F statistics than R square value. So but F statistics is not as significant, and we are not happy about this model. And also here you can see, out of these three variables, only one is significant and other two is not significant. And the guideline is that most of the independent variables should be significant to be a good model. But here only one variable is significant out of three. So this model is not a good model. And also F statistics is not as significant, meaning that x1, x2, x3 jointly cannot affect y. So that is not also good for this model. Okay. And now we can check some more things, such as, okay, this model, we can check this model is a time series model because we have the data from the year 2000 until, I think data is until 2000 until 2007, right? So normally we do not check heteroscedasticity, right? But still we can check the heteroscedasticity of this model. Okay, how to check the heteroscedasticity? I go to statistics, then I go to linear model, then linear diagnostic check, then specification test, then I check test for heteroscedasticity, this one, right? I select this one, test for heteroscedasticity, then I press OK. So here is the test, Bruce-Pagan test, right? And what is the null hypothesis? Null hypothesis is constant variance. So what does mean by constant variance? Constant variance means, it means homoscedasticity. Homoscedasticity, that is null. And what is alternative? Heteroscedasticity. And here the null hypothesis is desirable, right? Okay, and here is the chi-square value and corresponding probability. How much is the probability? 56.53%, which is more than 5%, meaning that we cannot reject null hypothesis. Rather, we accept null hypothesis, meaning that we accept constant variance, meaning that the residuals are homoscedasticity. So I am telling again, it means that residuals are homoscedasticity, and that is desirable. So we are happy about the model because the residuals are homoscedasticity, and that is desirable. And heteroscedasticity is not desirable for a model. But here the residuals are homoscedasticity. So we are happy about our model Okay, then we check whether this model has serial correlation or not, meaning that whether the residuals are serially correlated or not, right? So that we want to check. That means whether this model, whether the residuals are autocorrelated or not. That we want to check. Okay, how to check it? So I go to statistics, then time series. Okay, first we need to we go to time series, go to setup utilities, and declare data set to be time series data. So we have to do it first. We have to do it first to check serial correlation or autocorrelation. Actually, serial correlation and autocorrelation is the same meaning. But we have to declare first, right? So that we are doing now, right? Okay, here is a time variable and we take the OBS. What is OBS? Observation. And our data is yearly data. I select yearly. Okay. So you see it is done already, right? It is the time series data that we have set right now. Okay, now we can do the serial correlation, right, for our model. So here, what is the null hypothesis? The null hypothesis is residuals are not serially correlated, right? That means that is the null hypothesis, and alternative is residuals are serially correlated, right? Okay. The question is that what does mean by serially correlated? Also, we can call it autocorrelated. Same meaning, right? Same meaning. And here, the null hypothesis is desirable, and alternative hypothesis is not desirable for a model. Okay, now we check. So how to check it? As before, I go to statistics and linear model, then linear diagnostic checking as before, then specification test, right? I select. Okay, here you can see many tests, right? So first I choose, suppose this one. We can choose Bruch-Gottfried test, right? Durbin's alternative test. We can check this one first, right? We can check this one, Durbin's alternative test. Okay, the result has come up. Durbin alternative test for autocorrelation, meaning that serial correlation, and it is the null hypothesis, right? No serial correlation in the residual. That is the null hypothesis, and probability value is 18.76%, which is more than 5%. So when the probability is more than 5%, we cannot reject null hypothesis. Rather, we accept null hypothesis, meaning that we accept this one, meaning that there is no serial correlation in the residual that is desirable. So we are happy about this model. And we have also the same test for autocorrelation or serial correlation. So I go to statistics as before, linear model, regression, diagnostic, specification test, right? So that is this one, Bush-Godfrey test, right? That also we can do, right? Okay, Bush-Godfrey LM test. And what is null hypothesis? No serial correlation. That is null hypothesis. And what is p-value? 8.68%, which is more than 5%, meaning that we cannot reject null hypothesis. Rather, we accept null hypothesis, meaning that there is no serial correlation in the residual of this model. So we are happy about this model because there is no serial correlations. Actually, this test, Durbin test and Bush test, telling the same thing, that there is no serial correlation. So we are happy about the model. Okay, then finally we want to check whether residuals are normally distributed or not. Null is residuals are normally distributed, and alternative, residuals are not normally distributed, right? So that is the alternative hypothesis, right? And here the null hypothesis is desirable for a model, and alternative hypothesis is not desirable. Okay, now the question is that what does mean by residuals? Okay, residuals means, here I just tell you, residuals means actually actual y value. What is y? Dependent variable minus fitted y value. That is called residuals actually. Actual y value and fitted y value. That is called residuals. The gap between actual and fitted of the dependent variable, right? And we want that these residuals should be normally distributed. Okay, but the thing is that first we have to create the residuals. After that we can check whether the residuals are normally distributed or not. Okay, first I create it. First I create the residual. Okay, how to create the residual? I go to statistics, then I go down, further down. Okay, I go for post estimations, right? post estimation. Then I go to prediction residuals. You can see from here, right? Okay, prediction residuals. I select it. Okay, and then the new variable name, meaning that the name of the residual, I give it E, right? Name of the residuals. And here are many options. I choose the second one. I select the second one, residuals equation level score. So actually this one means actual y minus fitted y. That would be E, right? Actual y minus fitted y. So that would be E. Okay, so we are set. So I press OK. So this E has been created. How? So I check from my data. You can see from here, this variable, E variable, has been created, and that is called residual, meaning that actual y minus fitted y is residual, that is E. And we want to check whether this residual is normally distributed or not. That we want to check. Okay, how to check? As before, I go to statistics, then I go to summary tables and test, then I go to plots and test. Then here I check the Shapiro-Wilk test of normality, right? Shapiro-Wilk normality test. So I select it. Okay, and they are asking for variables. So we want to check E, whether E is normally distributed or not. That we want to check. So I have selected E, then it is set. I press OK. So this one is the Shapiro-Wilk test of normal data. Okay, here what is the null hypothesis? Null hypothesis is residual are normally distributed. That is the null hypothesis, right? And here what is the probability value? 93.445%, which is more than 5%. So we cannot reject null hypothesis. Rather, we accept null hypothesis, meaning that residuals are normally distributed, and that is desirable. So we are happy about this model because residuals are normally distributed. Okay, so we are done so far. Thank you very much for being with me.